All right, let's get straight into it. We're going to break down one of your most important required practicals for GCSE physics, number 5, all about density. Nailing this isn't just about passing the exam. It's about understanding a really fundamental property of, well, everything.
So let's start with a question that gets right to the heart of this practical. Imagine you've got something like a key. It's not a nice, neat cube, right? So how on earth would you go about measuring its density? It's a tricky little problem, and the solution is actually pretty clever.
So here's our game plan. We'll start with the basics, what density actually is. Then we'll look at how to measure it for simple, regular shapes. After that, we'll tackle those trickier, irregular objects. We'll then connect all this to the working scientifically skills you're marked on. And finally, we'll wrap up with how to smash the exam question.
Okay, first things first. Let's get a solid grip on the fundamental concept here. What are we actually talking about when we say density?
In simple terms, density is all about how much stuff, that's the mass, is packed into a certain amount of space, which is the volume. Think about it. A kilogram of feathers and a kilogram of steel have the same mass, but the steel is way denser because all that mass is crammed into a much smaller volume. And the formula you absolutely have to know is this one. Density equals mass divided by volume. Simple as that.
Right. Let's move on to actually measuring this stuff. We'll start with the easy one, regular objects. We're talking about things with nice, straight sides, like a cube or a rectangular block.
This is a really straightforward 4-step process. First, you just grab a ruler and measure the dimensions, length, width, and height. Step 2, you use those measurements to calculate the volume. For a block, that's just length times width times height. Step 3, you pop the object on a balance to get its mass. And finally, step 4, you plug your mass and volume into our density formula, and voila, you've got your answer.
But what about our key from the beginning? Or maybe a rock? You can't just use a ruler on those, can you? For these irregular objects, we need a much more clever technique to figure out their volume.
And this slide really shows the difference. For a regular solid, like a cube, you measure and calculate. But for an irregular one, like that rock, we have to measure the volume indirectly, using something called a displacement technique. This is where it gets interesting.
Okay, so let's walk through this displacement method. First, you get the mass of your object using a balance, same as before. Then, you part-fill a measuring cylinder with water and note down the starting volume. Next, you carefully lower your object into the water, making sure it's fully submerged. The water level will rise, right? Well, the amount the water level has risen by is the exact volume of your object. It's brilliant. Once you have that, you just use the density formula again.
And you can see how the numbers play out right here. Let's say we measured the mass, and it was 0.08 kilograms. And then, using our displacement method, we found the volume was 0.00001 cubic meters. You just divide the mass by the volume, and you get a density of 8,000 kilograms per cubic meter. It's the exact same math, just a different way of finding the volume.
Now, this is super important. This practical isn't just about getting a number at the end. It's about demonstrating that you can work like a scientist. So let's look at what the examiner is actually looking for.
Seriously, remember this. The examiner wants to see your technique. They want to see that you're being accurate and careful, and that you understand the whole scientific process behind what you're doing. It's about the how just as much as the what.
And this table here is absolute gold. It literally connects what you're doing in the lab to the specific skills AQA is grading you on. So when you choose a ruler, that's selecting appropriate apparatus. When you read the water level, that's making and recording observations. Doing it again to check for mistakes, that's about ensuring your results are repeatable. See? Every action has a purpose.
All right, we're in the home stretch now. Let's talk about how to absolutely nail this in an exam. We're going to cover the common mistakes and give you some pro tips to avoid them.
These are the classic trip-ups. First, parallax error. Make sure you read the measuring cylinder at eye level to get an accurate reading. Second, don't just drop the object in and splash water out. Lower it in gently. You also have to make sure the object is completely under the water. And a really common one, don't forget to measure the mass before you start. Finally, just double-check your calculation. Knowing these pitfalls has half the battle.
And it all comes down to this one simple idea, straight from the AQA specification itself. The whole point of being careful is to get an accurate measurement, one that's as close to the real value as possible. That's the goal of any scientific experiment.
So, you've now got the tools to find the density of any solid object you can think of. But here's a final thought to leave you with. How would you adapt what you've learned to find the density of a liquid? Think about it. You still need mass, and you still need volume.
How would you measure those for, say, a glass of water? It's a great way to test if you really understand the core principles.